Hi guys. So yeah, for those of you who don't know who we are, we're UK NEQAS Cellular Pathology Technique. We're an external quality assessment scheme and we provide quality assurance for all aspects of cellular pathology. So not just digital pathology, but all areas of how you create a slide. What I thought I'd do, because I've done this presentation a few times this year, so I thought it's the time of the year where everything's coming to an end and I'm just going to do a summary of the scheme, but I thought I might do it in the form of a Spotify Wrapped because it's just that time of the year. We've all received our Spotify Wrapped, or have you used Strava? Strava Wrapped came out today as well. But yeah, this is just how we implemented a digital pathology external quality assessment scheme and how it's gone this year. Um, the aim of the digital pathology quality assessment scheme is to assess the quality of the digitisation of a glass slide. So if you are familiar with who we are, you know we've assessed glass for years. As it was alluded to when Joe mentioned it, there's been so many glass schemes for so many years. But with the advent of digital pathology, we need to provide a scheme that assesses the quality of how this has been digitised. So we compare the glass and the image. We look at the technical quality, how the slide's been prepared. Is there any artifacts that are going to affect the digitisation of the glass slide? And is it standardised? Are our participants doing it the same way? How are they getting this image? Even though we're called UK NEQAS, we're not just a UK-based company, we're a global company, and we have a lot of international participants as well. So we all know the benefits as well of digitisation. It enables remote reporting and also the direction we're all going. And the theme of this event has been that we're going in the direction of using AI or computational algorithms to assess. But this is only going to work if the digital image truly represents the glass slide. So just the timeline of how the scheme's been developed. From about 2017, we started issuing surveys to our participants just to gauge the uptake of digital and just kind of to give us that demand. We developed a working group and we just had a lot of ideas that were thrown around. We had a pre-pilot assessment last January and it all went wrong. We were using Google Drive for our participants to upload images, and we all know that's just not ideal. Our infrastructure within our office was not ideal either. So we are based in Newcastle. We're office based. We just had some small computers, some small monitors. We didn't have anything with regards to GDPR or data protection in place to cover the submission of the images to us. It just wasn't ideal and it all went wrong. So we kind of fixed all of these things. We invested in our infrastructure. We got computers with the correct RAM, the correct graphics cards, the correct monitors, because again, this was a discussion that was had yesterday from NPIC about how important it is to have the correct monitors to look at your digital images. Although we're not a diagnostic scheme, it's really important that we have we have monitors that are designed to be looking at digital pathology images. We also started training assessors. So obviously all of our assessors are so used to assessing from the glass. The way it's set up in our office is we have multi-headed microscopes. Everyone's used a microscope, and we had to train a new generation of assessors who have been involved in the implementation of digital within their own organisations. It's just really important that we got assessors that have that experience. So because the pre-pilots were successful, we decided to go to full pilot. We had our first pilot with 18 participants in January this year. We had our second pilot, which had 31 participants. And we used these pilots to learn, to develop our assessment criteria, what it is that we're actually going to assess. We originally had two sets of assessment criteria where we had one for the slide and one for the image, and we combined the two. And I'll go through that a little bit later. Because the pilots were so successful, we did have our first run in June this year, and there was 45 participants who signed up for that. And just as the year has gone on, we've had 3 successful runs now, but actually on Friday we had our 4th one. But you can just see the participants are growing with the scheme as well. So we know there's been a rapid shift in the uptake of digital pathology and whole slide imaging. And while glass slides have been well-established EQA schemes, digital image analysis did not have this, so we had that gap in quality. So that's why we developed this scheme. So how does the scheme even work? So our participants submit their images to us. They submit the slides, so they'll send the glass slides to us just in the post as they do for our usual glass schemes. And then they submit their images to us using we've worked with a company called Pulse who developed Pathogate. So Pathogate is a piece of software. It's cloud-based. It's accessible through the internet. They just log into Pathogate and they do the upload, the hosting, and the image viewing system for us. It's a way that our participants can upload their images, and we can accept all file types apart from iSyntax, which is proving a little bit difficult for some of our Philips customers, but we have found ways around this. I can show you how Pathogate looks. So this is just what Pathogate looks like. Our assessors, they'll select the image they want to look at. When our participants upload their images, they're asked a series of data entry questions, which you can see there. Our assessors get access to these answers, and it kind of aids in the assessment as well. What just happened there is if an ICC colour profile is applied, we can see the original raw image and the image that has the colour profile applied. We assess the image that has the colour profile applied because that's the one that our participants are doing their QC checks from. Our assessors can annotate whenever they've seen an artifact or something, they can annotate, they can circle it, and again, it just helps us with education for our participants. If they have any queries about why they've scored what they have, we can go back to the image and show them. It's just really easy to use, and we're really lucky that this company developed it for us. Because we're a non-profit charitable organisation, we don't have the funding there to go to someone like Sectra to develop this for us. So again, this is just why it's came in so handy. All images are assessed on site. So they come up, all of our assessors come up to our office in Newcastle and they work in pairs. We also provide assessments of late submissions. So if our participants don't submit their images and the slides on time, we'll go back and we'll assess the slides from previous runs for them. And we can also, if anyone wants to appeal their score, we can do that for them as well. So each submission is reviewed for key artifacts and technical issues. So we do look at microtomy artifacts and pore staining artifacts that are going to affect the digitisation. And then we do look at imaging artifacts as well. So I can show you what our criteria looks like. So you can see we do look at a lot of pre-analytics. And what we'll do, our assessors will look at the slide, they'll look at the image. And before they've started considering the score, they're just going to tick what they see. So if they see folds and creases, they're going to tick folds and creases. If they see a bit of displacement, they'll tick displacement. If they see stitching and striping artifact, it'll be tick, tick, tick. But then when it comes to considering the score, they have to consider how these artifacts actually do impact on the quality of the digitisation. So if they've seen folds and creases, but they've been scanned beautifully and they're all in focus, you're not going to lose marks for that. It's still an excellent score. However, we do still tick that we've seen it because what we want to feed back to our participants that these artifacts are going to affect algorithms and AI analysis in the future. If you've got folds and creases, it can affect the output of the algorithm. So again, it's just we're so heavy on education within our scheme as well. We're not there to tell people off. We want people to improve, and if anyone has any issues, they can come to us and we can go through it with them. So our assessors give a score out of 5 each. So our participants get a score out of 10. So 10 and 9 being excellent, 8 and 7 being good, 6 and 5 being a pass, and 4 and below being a fail. So this is just an example of how our participants have performed over the past few runs. You can see the majority of them are scoring good, so they're getting that 8 and 7 score. We've had a select few getting 9 and 10. However, compared to some of our other schemes, we do have quite a high failure rate for this as well. I do have some examples of why people are failing, but it tends to be because if the entire piece of tissue that's on the slide is not on the image, say it's not within the scanning area, and we're not a diagnostic scheme. So say you submit a piece of bowel that has a lot of fat around it and the fat is not in the image, we will still fail that because we expect everything that's on the slide to be on the image. So why do we look at the criteria that we look at? There's a lot of literature out there that explain the importance of how colour can impact AI in the future. So these are just two examples. The image on the left is what the slide looked like down the microscope. The image on the right is the digital image that was uploaded to us. And you can see there, the two are not the same. And it's just really important that the coloration should be the same. And again, this is just something that we consider. 27% of our submissions so far have had image colours that didn't match the glass slide. We have a little look at some of the pre-analytical artifacts that we've had submitted. So number one is folds and creases. I did use that as an example because it is something that we need to start considering the quality within our labs. So something as simple as when you first become a BMS or you first start using how to use a microtome and, just going that little bit slower, just getting some nice sections. It's just really important to feed back to our labs how important that just foundation step of histology actually is for the downstream processes that we're wanting to use. This is just an example of some folds and creases, but you can see yourself they're in focus, they're beautiful. This person didn't lose any marks for this. And the same for this one. Again, it's a lovely fold. It's been imaged beautifully. However, when we start having folds and creases where it starts knocking it out of focus, then we do start removing marks for this. And this is just a worst case scenario where I've got a lot of folds and creases, a lot of areas that are out of focus. We do get a lot of displacement. Again, it's just these foundational histology skills where we just need to improve it in the future. So 47% of our submissions had displacement. And chatter, again, just slow it down, cool your blocks down, make sure you're not getting chatter because again, AI will pick this up in the future and they may think it's something that it's not. 38% of our participants demonstrated chatter. And again, just something like contaminant on the slide. So there's quite a large piece of contaminant on there and it's covering quite a large area. It's just, again, it's just little quality things that just need to improve. When we start considering imaging artifacts, these are a different kettle of fish, really. So 32% of our submissions demonstrated background artifact, like here. So this is just a visual distortion. Actually, you can't really see that. It's obviously a projector that's not demonstrated. It's not used to demonstrate digital images, but what I can see is there's lots of pixels, there's lots of little squares going across in a pattern across the image, and it goes across the tissue as well. So it's like a visual distortion. It's quite distracting to pathologists, and this should be clear. So this can just be fixed by just calibrating the scanner or, fixing the white balance. Okay, you should be able to see. There's a line. This is stitching and striping artifact, and it's just where there's been a misalignment. Yeah, there's been a misalignment when it's took the image and it hasn't stitched the images together because the scanners, they capture multiple adjacent tiles and it hasn't stitched the tiles together. You can see there's a rectangular patch in the center of this image. It's just a tile that's out of focus. And again, it's just when it's captured that tile, it's just been knocked out of focus, but it's defined, it's got well-defined edges around it. And again, this just rescan the slide. When you're doing your QCing, just rescan the slide. Tissue positioning. So again, this is coming back to why our participants fail. You can see yourself, there's tissue that's gone outside of the scanning area, and it is just an immediate fail for us. So digital pathology doesn't eliminate technical variation, it exposes it, as we've just seen. And our EQA scheme provides a framework to measure and improve this. So building on this foundation, what we're going to do in the future, we're going to develop companion schemes. So at the moment, our digital pathology scheme is just looking at formalin fixed, paraffin embedded H&E slides. we've surveyed our participants and we know that the majority of them are scanning their ICC slides, they're scanning special stains. 50% of them are scanning the frozen sections, which is a bit of an iffy area because they shouldn't potentially be doing that because the scanners aren't designed to be scanning unfixed tissue. So yeah, we're going to have some pilot schemes running out in the new year for ICC special stains. And what we're also going to do is use this foundation to develop an AI proficiency testing scheme to support safe and standardized evaluation of AI diagnostic tools in pathology. Oh, this was just giving me examples. Thank you for listening. If you would like to consider being an assessor for our scheme, because it's such a brand new scheme, and we do have quite a small assessor pool, if you would like to consider being an assessor, just send me an email and we can have a chat about it. Any questions?